Yesterday in class, you learned how to simplify expressions where we have a quotient to an exponent or a quotient to a power. Today we're going to review that in this first problem and then go through some examples of how to simplify when that exponent is negative. And there are a couple of ways to go about that, but we have to be very careful within those steps. So we know that when there is an exponent on the outside of these parentheses, it goes to everything on the inside, both the numerator and the denominator. And when it's a power to a power, we need to multiply those exponents. So x to the fourth to the third gives us x to the 12th. When we put that over 3 to the third, and then from there we simplify it because 3 to the third becomes 27. And then from there we have no negative exponents, no zero exponents, and there aren't any values that we can simplify any farther. So this would be our answer. And again, this 3 went to both the numerator and the denominator, each part of the fraction. Today, when we look at the negative exponents, the only way we can simplify a negative is to have that item cross the fraction bar line. And when we simplify a problem like this that has a large group of parentheses, a quotient, to a negative exponent, there are two ways to do it. You can distribute the negative exponent first, keeping it negative, or you can take care of the negative exponent and then distribute. I'll show you both ways and then we'll do some practice problems. In this first one, if we distribute it first, that gives us 4 to the negative second power. Notice how the exponent is still negative, and 3 to the negative second power. It goes in to both of them. Now the only way to actually simplify 4 squared is to make this no longer a negative exponent. So to do that, it has to cross the fraction bar line. So the 3 squared comes up and now it's positive. The 4 squared goes down and it's also positive. Then from there we can finally simplify the exponent because neither of the exponents are negative, giving us 9/16. You'll notice the other strategy of doing it is the exact same steps, and I find that it's actually more helpful for students because then we don't forget to take care of the negative. So if we take care of the negative first by moving everything on the inside to the opposite side of the fraction bar line, then we keep the parentheses the first time, putting 3 over 4, and the exponent is now positive because everything moved across the fraction bar line. Then we distribute it to both the numerator and denominator, giving us what we had before, 3 squared over 4 squared, and simplify it. Let's try the next one. Again, two ways. If we distribute first, a power to a power, we multiply. So that gives us m to the negative 10th. Power to a power for this one, again, we multiply, giving us x to the negative 30th. Notice how both of these are negative exponents. So to get rid of the negative, we have to put them across the fraction bar line, giving us x to the 30th and m to the 10th. They are not like bases, so we can't simplify any farther. The other way we can simplify this is by taking care of the negative first. To do that, the x to the 6th goes up, the m squared goes down, both of which still need to be in parentheses, and now this negative is a positive 5. Then we would distribute to both the numerator and denominator, giving us x to the 30th over m to the 10th. Again, not like bases because they're different variables, so this would be our answer. The third example of showing both ways to simplify this quotient to a negative exponent has this coefficient of 2. This negative 3 is going to have to go to that 2 first as well. So in the one strategy, we can distribute first. In our other strategy, we can take care of the negative exponent first. Again, I find that students are more successful with taking care of that negative exponent first. but we'll go through both strategies. If we distribute first, we have 2 to the negative third power, and then this is again a power to a power, so we multiply and we get x to the negative 18th power. Then we distribute to the denominator. Again, we multiply them together, giving us y to the negative 12th. And we've taken care of the exponent distributing it in, but this time, again, we have 3 negative exponents. So this needs to move down, the x needs to move down, and the y needs to move up. So now we have y to the positive 12th over 2 to the third, x to the 18th. And from there, we have one more piece to simplify, because we know that 2 to the third is 8. So that gives us 8x to the 18th under y 12th. Again, not the same variables, no fraction to simplify, so this is our final answer. If we look at this next one, again, exact same problem, but this time we're going to take care of the negative exponent first by moving everything across the fraction bar line, but still keeping it in our parentheses. And now this 3 of an exponent is positive. From there, we need to distribute to each part, giving us y to the 12th. The 3 not only goes to the x to the 6th, but also to the 2, so we have 2 to the 3rd. That's probably the piece that's missed the most often when we have the coefficient. And then x to the 18th. And from there, we have one more step to simplify 2 to the 3rd. And it's the same answer as what we had before. Again, taking care of the negative exponent first by moving everything across the fraction bar line is helpful, because then you know you took care of the negative exponent. So we're going to practice that strategy and a few more. We're going to take care of this negative exponent by moving everything across. So then we have n over m, still in parentheses, that part is super important, to the 3rd, and then we distribute it in, giving us n to the 3rd over m to the 3rd. Different variables, so we cannot simplify any farther. For this next one, you'll notice that we have coefficients for both of them, so we have to keep that in mind. But again, we're going to take care of that negative exponent first by moving everything across. And it's still in our parentheses. Then we distribute the 4 to each part, the 5, the y, the 3, and the x, giving us 5 to the 4th, y to the 16th, because it's a power to a power, 3 to the 4th, and x to the 8th. I'm writing the 5 to the 4th and the 3 to the 4th like this rather than simplifying right away, because I find that many of us right now are multiplying the numbers instead of keeping it as an exponent. This 4 is an exponent, so when we distribute it in, it has to remain an exponent. We multiply to our 4 here that is an exponent and the 2 here that's an exponent. But when it goes to our coefficients, it has to remain an exponent. Then from there, when we simplify, 5 to the 4th gives us 625, y to the 16th, and 3 to the 4th gives us 81, x to the 8th. And then from there, these two numbers do not divide nicely for us, and we cannot simplify them, so this is our final answer. Again, for this next one, we notice here that for the first time, all 3 of our variables inside our parentheses are a's. So before we deal with this exponent, we can simplify everything inside our parentheses. So that's what we're going to do. A to the 4th times a to the 1st gives us a to the 5th, and we put that over a squared. Our exponent is still a -3. We can still combine these because we're dividing like bases, so we're going to subtract their exponents, giving us a to the 3rd. We have 3 more on top than on bottom. Again, still in parentheses, to the -3rd power. Then from there, we can either distribute or take care of the negative. Because it's not a fraction already, it's easier to just distribute because it's a power to a power, giving us a to the negative 9th. And then from there, we cannot keep this negative, so we write it as 1 over a to the 9th. And we didn't have to worry about distributing it to multiple places because all of these were the same variable, they're like bases, so we could simplify first and then only distribute it into one place. It's similar in this next one, but this time we still have our coefficients. We can take care of our variables inside our parentheses and go from there. So in this case, if we subtract, we would get x to the negative first power. Otherwise, we can think of it as we have one more x on the bottom, so we're going to keep that x on the bottom. Since it was one more, it's going to have an exponent of 1. Again, it's still in parentheses. Our exponent is still a negative 2. Now we're going to take care of this negative by moving everything across that fraction bar line, giving us 5x over 2 in parentheses squared. Then from there, we're going to distribute. It goes to the 5, the x, and the 2 in the denominator. So we have 5 squared x squared over 2 squared. And then when we simplify that, we get 25x squared over 4. Again, this does not divide nicely, so we'll leave it as the most simplified form of an improper fraction for our final answer. Again, simplifying the x squared and the x to the third in the beginning helps simplify when we actually do have to distribute in. If we were to expand out this x squared and x to the third, we would have x times x on top with x times x times x on the bottom, and 2 of them would cancel out, leaving us with just the 1 x on the bottom that we had here. Let's try a couple more. Notice this time for the last 2, we have a negative on the inside of our parentheses. Because it's inside the parentheses, the exponent is also going to this negative. The first thing we're going to do, since we don't have like bases inside our parentheses, is take care of this negative sign. This is going to happen first. So we're going to flip everything across the fraction bar line. The negative is still going to stay inside our parentheses, so those parentheses are really important. We have 5y to the 4th over 7x to the 5th. We've flipped everything, so now it's a positive 2 as our exponent. Then when we distribute that in, it also goes to that negative. And a negative times a negative gives us a positive, so we no longer have to write that negative sign. So then we have 5 squared y to the 8th power over 7 squared x to the 10th power. And then we just have one more final step to simplify, giving us 25y to the 8th over 49x to the 10th. Again, this cannot be simplified, so this is our final answer. This negative became a positive because of this even exponent. You notice in this next one, our final example, that it's an odd exponent, so we'll treat it very similar, but it'll change that negative answer in the end. The first thing that we're going to take care of is this negative exponent by flipping everything. Again, the parentheses and that negative are still needed in this step. And we took care of the negative, so the 3 is still there. Then when we distribute it in, it also goes to that negative sign. And this time, if we have a negative times a negative times a negative, these two together make a positive, and a positive times a negative remains a negative. So we know that this is still going to be a negative, giving us 3 to the third y to the 12th over 2 to the third x to the 9th. Because we just distributed the 3 to each part of our quotient, including our coefficients, we no longer need parentheses, but we do need this negative sign. And then we just simplify our coefficients. 3 to the third gives us 27 y to the 12th, and 2 to the third gives us 8, and then x to the 9th remains. Again, it's a negative because it was an odd exponent, and 27/8 is our simplest form of that improper fraction. Okay, so remember that we have two different ways to simplify when we're working with a negative exponent and a quotient. We can distribute first, but keeping in mind that the negative is still there and we cannot forget that negative and moving everything across the fraction bar line. Or we can take care of that right away. Again, I find that students are more successful taking care of the negative first, then distributing, and then simplifying from there. When we get to problems where we have a coefficient, we want to make sure that our exponent is also going to that coefficient when we distribute. When we have like bases, we want to simplify first because it's going to make that distributing easier. And then when we have a negative on the inside, we need to pay attention to, is it an even or an odd exponent? Even exponents make it a positive final answer. Odd exponents will make it a negative final answer, as long as the negative sign is inside the parentheses.